Hello, let's do the New York Times Hard Sudoku for November 7th, 2025. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. All right, this box we got quite a few givens, 1, 2, 3, 9. I'm not seeing anything, okay, I am seeing one thing. Okay, I'm seeing the 2. I was going to say I don't see anything with the 1 and the 2, but I do see that this 2 looks down, and this 2 looks into this box. This is what I call a crossing. A crossing isn't really a technique. It's more of a scanning strategy, where in this case, we're looking at this 5, 8 here that share a column. So we want to look at this row for any digits that aren't placed in the box yet. So the 2 and the 4. And then we want to look at these 2 columns for anything that matches. So we have the 2's matching. And via that scanning strategy, that guarantees that if we find that we have something interesting about that digit in the box. It's either going to be pointing from 2 cells like this, or it's going to be a hidden single if one of these were filled. So the 2's point up, this 2 looks down, this 2 looks in, putting a 2 in one of these 2. And again, it's not like a special technique, it's just a way to scan for those that does make it a little easier to find those things. All right, so that's the 2. I'm also noticing this 5, 8 looks into this box here, and this box doesn't have 5, 8 yet. So the 5 and 8 end up over here. We have this 5 and 8. So I'm going to corner mark 5, 8 and clear out that 5 and that 8. So that's quite handy. And those are both going to point along with this 5, 8, putting the 5, 8 here. This 8 will eliminate 8 from here. All right, so basically what we learned is that these are not 5, 8, and we also learned that these aren't 2. So these aren't 2, 5, or 8 is what these corner marks are telling us. All right. So that was the 1 and the 2. I didn't see anything with the 1. I don't see anything horizontally with the 2. How about the 3? We do have 2 3s, so it puts a 3 in one of these 2. And then the 9. Don't see anything with the 9. Now, we already took care of, when we have a filled box column like this, we want to look at the other 2 columns for any digits that aren't placed, but we already did the 5, 8, so that's already been taken care of. The last thing I want to look at is in this box. Notice we have 1, 2, 3, 9 as givens and 5, 8 as corner marks. So that's a total of 6 digits that these 2 aren't, leaving at most 3 digits that they are. I'm seeing the 7's going to help out, the bottom one. And so is the 8. So actually, no, not the 8. Sorry, 8's up there. Just the 7. They're not 1, 2, 3. They could be 4. They're not 5. They could be 6. The top one can be 7, and they're not 8 or 9. So this is the 8. This is the 9. So 4, 6, and 4, 6, 7. I think from there, the last thing I'm going to do, somewhat related to this box, is to look at this row, which is down to 4 digits. We need a 4, 7, 8, 9. We know these aren't 8. This also isn't 4. So if I type out 4, 7, 8, what did I miss? Sorry, 4, 7, 9. It's like, what happened there? They're not 8. So 4, 7, 9, we can clear out the 4. This can't be a 4 or a 7. So this is 8, 9 only. And I believe this can be any of 4, 7, 8, 9. All right. Let's look at this 6, 8. So first we're going to do direct from the givens. 6 in one of these 3. That's all I see from 6. There is something interesting to keep an eye out on, which is both the 1 and the 6 look in here, and the 1 and the 6 look in here. So 1 and 6 are in these 3 cells. If we can limit 1 more digit to these 3 cells, then we'd have a hidden triple. Unfortunately, I do not see a way to do that. I am noticing we can place a 7, though, while I'm in this area. So let's place that 7. These 7s, put a 7 in one of these 3. This box is empty, but we're getting quite a few corner marks in it, which is nice. All right, so coming back up here, we have the 6. The 8 doesn't seem to do anything. All right, the other thing I want to look for, which we're not going to find it, but this is what I'm looking for, is this 6, 8. We want to look for a crossing, which would be any digit here that has a duplicate here that isn't placed in the box yet. Unfortunately, nothing matches. It would be the 3, and there's no 3's here. So we also already have 3 marked in the box. All right, so we're going to move on to this box here. We have the 3, 5, and 7. Whenever we have 3 givens in a box like this, especially if when they're avoiding a column or a row or both, we want to ask the question, where do 3, 5, and 7 go in that row or column or both? So 3, 5, and 7, we already found the 7, but we do need 3 and 5 in this column. And if we look, this cell here can't actually be 3 or 5. So there are only 2 places left in this column that can be 3, 5, and so they must be 3, 5. So this is what's called a hidden pair. Now, what have we actually done here? we've said, okay, this column needs a 3 and a 5. One of these will be 3, the other will be 5. So we can't put any other digits in there, is essentially the consequence. So we can think about the rest of the column to know what we eliminated from these two and then potentially act on that. So the rest of the column is 1, 4, 8, 9. So, oh no, not 4, sorry. 1, 6, 8, 9. Okay. This can't be 8 or 9, so this is just 1, 6. This can't be 6. This is 1, 8, 9. I think this be any 1, 6, 8, 9. But the key thing is to think about, is there any consequence to these not being 1, 6, 8, 9? So, for example, this can't be 6 anymore, and then this 6 looks up. So yeah, the consequence is in this box, there's only one place for 6 now, which is right there. These two 6s do look up, putting a 6 in one of these two. This also can't be 1 or 9. So it already couldn't be 6, 8, right? But now it can't be 1 or 9. And is there any consequence to that? So like this 9 looking down does put a 9 in one of these two. The 1 isn't as lucky. But we do have a few more things going on vertically here. This column has been reduced to 3 digits. We need a 1, 3, 4. This can't be 3. This is 1, 4. This can't be 3 either, or 4. 4. Oh, okay. So there's a few things we can do. One is this can't be 3 and this can't be 3. So the 3 is placed here, but also these two can't be 4. So the 4 is up here, and then that's the 1. So however you want to resolve that, it's going to resolve in the same way with the 1, 3, and 4 here. That gives us the 5 here and the 3. It resolves that hidden pair we found. This can't be 1 anymore. In fact, we just left with an 8, 9 pair in the box. This box is down to a pair, which is the other thing I was going to look at. This 4 looks in, so that's 5 and 4. And then this is 3 digits for the column. Looks like it's 2, 8, 9. And oh, this can't be 8 or 9. I didn't look for some reason. That's not a 4. That's not a 5. Now, we need to look carefully here. Yeah, so look at where the 5 and the 8 can go in this box. We can use our corner marks. It's these two cells here. So we found another hidden pair because the box needs both a 5 and an 8. One of these has to be 5, the other has to be 8. So I can get rid of these corner marks, but also that means this can't be 7 anymore. So the 7 corner mark is no longer valid. We can follow up by thinking about these 4 digits. We need the 1, 4, 7. So I missed something. 1, 4, 6, 7. So this is 1, 6 only, not 4 or 7. This is not 1, 6. This is 4, 7 only. This can't be 6, 7, so it's 1, 4, and this can't be 4, so this is 1, 6, 7. Interesting. So we know that the 4 is in one of these two for the column. And the 7 is in one of these two. Both of those are going to claim. Column 2 claims the 4 and the 7 from box 7 here. What do I mean by that? Well, if you think about it, we're going to be placing a 4 somewhere in this column. And we've tracked it down to either this cell or this cell. Wherever that 4 ends up, we can't put another 4 in the box. Same thing with 7. We can't put another 7 in the box. So none of these cells can be 4 or 7. Now this 4 already looked in, but these aren't 4 now. Can I do anything with that? Also, this 7 looks in, but these aren't 7 now. Yes. Almost. Sorry, no. I wasn't paying attention to this one, but I was thinking about 7 in this row, because now it can't be here. So 7 is here, and this 7 looks down. So 7's in one of these two, unfortunately. I had initially scanned that wrong, and when I double checked, I found that it wasn't quite as nice. I'm going to do some scanning here. I haven't... There's a lot of low-hanging fruit still. There's like this row here, there's this row here, but I feel like there's some really easy scans that I haven't gotten to yet because I didn't even finish this top band. So we're going to rescan the 2 and the 4 here. So we have these two 2s. Oh, sorry, I highlighted that wrong, but these 2s look in, putting a 2 in one of these 3. And then the 4 does not... Oh, the 4 actually is a crossing on this 6, 8. Remember we looked earlier? Puts a 4 in one of these 2. That points down with this 4. Putting a 4 in one of these 2. Oh, sorry, this 4 looks in as well. So all of these 4s looking in, these 4s pointing down, places the 4 in the box. If you notice, so I can place this 1, but also if you notice our corner marks, this is the only place for 4, and now this is the only place for 7, and that gives us the 1 and the 6. So this whole quad resolved. Also resolves this 6. I feel like this puzzle's collapsing on me after having found this hidden 3-5 pair early on. It might be only singles left. These 2 digits are the 2 and the 9. All right, not resolved. That was so low hanging fruit. I wanted to look at it. Also 3, I always want to look at right away. We need a 1, 2, and 9. This can't be 1, so it's 2, 9. These can just be 1, 2, 9. So you may be tempted, if you've learned about unique rectangles, to think that this is a unique rectangle, but it actually isn't because it's in 4 boxes. But we still, I mean, the only conclusion you'd have from it is that one of these two is 1, and we already know that that's true. But it's all not true because of the unique rectangle. It's just true because that's where they go in the row. But unique rectangles have to be in exactly 2 boxes. Exactly 2 rows, 2 columns, and 2 boxes. It's the 2 boxes one that people mess up. All right. Let's go back to scanning up here. Make sure I didn't miss anything. Oh, we have an 8-9 pair here, so this is just down to 1, 6. And then we have this 8-9 pair here. I feel like there's more going on in this band, but let's actually move on to this band, which has a completely filled box. So this 4 and 7 and this 4 and 7, that tells us that this is a hidden 4-7 pair, if I can type the correct digits. So we just eliminated something from there. So we got a 5-8 pair and a 4-7 pair. It leaves 4 digits behind. Remember, this box had no givens from the start. We need a 1, 2, 3, and 9. So we know this isn't 2, so this is 1, 3, 9. Not a 9 either. So the 9's down here. That point's telling us this isn't a 9. And then this isn't a 9, so this is 1, 2. Oh, it's not a 1 or a 9, so it's 2, 3. Sorry. This 1 looks in putting a 1 in one of these two. And the 3 is in one of these two. 1's in one of these two. 3, 9, 1, 2. Why is this? Oh, I had the 2's in one of these two. Why did I say that? That is true of the column. It means I shouldn't pencil a 2 in here. It claims. I don't know if it was initially a mistake, but it is true of the column. That 2 goes in one of these two. I don't know if I found that in some other way. I don't know where those corner marks came from. But they are true. The other thing I'm seeing in this column is that we have a 4, 6, 7 naked triple. I apologize. I always have to explain this. I apologize to my veteran viewers. I always have new viewers, and this is the one that I get the most questions about. So I'm going to go over it carefully. I try to every time, unless I'm feeling a bit like rushed. But this is a naked triple. It is different than the hidden stuff we've been doing. Naked means just look at what we center marked. So the key here is that in these green cells, I cannot repeat digits because they're all in the same column. So I need 3 distinct digits to put into the green cells. Now, if we go through each of these, I'm going to just count on my fingers how many distinct digits we've encountered. So here we've got 6 and 7. That's 2 digits. Here I've got 4. That's a new one, but 6 is not new. We already said 6 in the 6, 7. Then down here we've got the 4, which we already said here, and the 7, which we already said here. So on my fingers here, I've got 3 unique digits, and you can see this in your head relatively easy, just kind of grouping it in your head. At least with practice, you can see that this is 4, 6, 7 only. So if I need 3 different digits to put into green, and the only 3 digits available are 4, 6, and 7 within these cells, then that means one of them's going to be 4, one of them's going to be 6, and one of them's going to be 7. And so that means that I can't put in the rest of the column any more 4s, 6s, or 7s. So, for example, we thought this could be a 6. But look what happens if we actually put a 6 here. This ends up 4, this ends up 7, and this ends up empty. And we can't use empty cells. Or it ends up repeating a 4 or a 7. It needed the 6 in that case. So we can't get away with not using a 4, 6, or 7 in these greens. So that is what makes it a naked triple. I'm going to keep that green for a second. And so that eliminates 4, 6, and 7 from the rest of the column, leaving behind 2, 3, and 9. This can't be a 2, so this is 3, 9. Okay, oh yeah, I had these pointing 2s. That was already marked. That's exactly why I shouldn't have penciled 2 in there. Sorry, I just noticed. Anyway, the other thing we can see from this triple, but you can also now see it from the column now that we've eliminated, is that, remember, we need to place a 4 into one of these 3, a 6 into one of these 3, and a 7 into one of these 3. But this one cannot be the 6. Meaning the 6 must be in one of these 2. And so that is going to claim. That's going to tell us that these can't be 6. The rest of the box can't be 6. And so what that's going to do is tell us that 6 is somewhere over here. But this can't be 6 and this can't be 6. And now this can't be 6. So the 6 is placed here. So this is down to 2, 9 only, meaning the only place for 3 in the box is right here. That This 2, 9 is going to give us the 1 and the 3, or if we prefer, we can just place this 2, which gives us the 9, the 1, and the 3. So we just collapse it in 2 different ways. That's a 2. All right, that gives us the 9, 2, and 9. So this here, by the way, even without this 2 placed, this is a unique rectangle. So let me go over that. This is not a technique I use in my walkthrough solves because it is not a technique that is ever required. And also, I kind of have a distaste for uniqueness techniques myself, unless the puzzle kind of requires it. These puzzles never do. But it is a technique you can use if you're careful and you match it up exactly. So what do I mean by this being a unique rectangle? Well, what would happen, we're ignoring this 2 for a second. What would happen if this were a 2 or a 9? Well, look at the consequence. We have a 2, 9 pair in this column. So the entire rest of the column, I'm going to mark that gray, cannot be a 2 or a 9. Same with this column. None of those can be 2 or 9 because of the 2, 9 pair. And then the rest of this row, none of that can be 2, 9. And the rest of this row, we have these 2, 9 pairs. Look at that. We also have a 2, 9 pair in this box. We have a 2, 9 pair in this box. So none of these gray cells can be a 2 or a 9. So how the heck would we resolve this 2, 9 without the use of the gray cells? And the answer is there is no way. You can only resolve it by having a 2 or a 9 somewhere in the rows, columns, or boxes, but none of those can be 2, 9. And so that means that in our solution, there would be two solutions at least. One with the 2s here and the 9s here, and one with the 9s here and the 2s here. And we know that the New York Times does not publish puzzles with more than one solution. And so if we add the assumption that there is only one solution, then the only conclusion we can have here is that this cell cannot be a 2 or a 9. And so we can eliminate 2 and 9 from it. Now, of course, we can do that also just by placing this 2, but I thought I'd point that out, that we do have this here. Very useful technique to know, but do keep in mind it must be in 2 boxes. If it's in 4 boxes, you cannot do it. So this 2 does resolve the 2, 9 pairs that we had here. That also tells us that can't be 2, 9, by the way. But I thought I'd point that out before I got past it. That's 7, that's 4. That's an 8. It's not always trivially obvious. Like sometimes uniqueness can just kind of bypass the rest of the puzzle and finish it for you. And sometimes it's fairly useless. So, but it is a technique to have in your belt if you are willing to use it and you know that there's a unique solution. This is a 1, 2 pair. Sorry, not 1, 2. This is a 1 something pair. This is a 1, 8 pair for the row, but this 8 looks down, so it's 1 and 8. And then this box needs a 2, which goes here, and it needs a 4. No, I keep scanning wrong. That's a 7. All right, this 2 looks up, giving us the 2 here. All right, lowest hanging fruit appears to be this pair here. We need a 5 and 9. This 9 tells us the order. That's going to resolve our 8 and 5 here. This needs to be a 1. These 2 digits are a 3 and 8. This 8 looks in, places the 3 there. This digit, we need the 1. That's 6 and 1. That's 7. This is the only place for 6. We get the 4 and the 7. These 2 digits are the 4 and 5. This 4 tells us that's 5, 4. And then here we need the 5 and the 9, and we're done. Ah, nice. 69 self-counter. All right. I mean, 18 minutes, but I spent a long time explaining a triple and unique rectangle and other stuff. So I don't mind taking the time to do these explanations because the whole point of these videos is to help you get better at solving Sudoku. And finding, and in addition to that, it's also a very fun way to solve Sudoku, in my opinion. And so an important aspect to this whole thing is having fun. And there are definitely not fun ways to solve Sudoku. And I think that this is the most fun way, in my opinion. All right, well, let me know how you did. And if you enjoyed this, why not leave a like, subscribe, and a kind comment below.